All right, so let's look at some questions on linear momentum and collision. Question 1A is saying a ball of mass 0.250 kilograms moves on a frictionless horizontal floor and hits a vertical wall with speed 5.0 meters per second. The ball then rebounds with a speed of 4.0 meters per second. If the ball was in contact with the wall for 0.0150 seconds, find the average force that acted on the ball. Find the average force that acted on the ball. So we're going to get some information that they've given us here and what data have been given from here. Okay, so we've been given the mass of the ball, very important. For our data, we've been given mass, say it's 0.250 kilograms. We've been given V initial, which is V0 in this case, to say it's 5.0 meters per second squared. We've been given V final. They've said it's 4.0 meters per second, but since it is in the opposite direction of the initial motion, which was in the positive direction, it is going to be negative. So our final velocity is negative 4.0 meters per second. And they've also given us the time frame in which the ball is in contact with the wall. So we're going to say the change in time, or delta t, is equal to 0.0150 seconds, like that. Okay, so we've been told to calculate the force, the average force that is produced when the ball is in contact with the wall. So we know to say average force multiplied by time is equal to change in linear momentum. That means our force will be equal to what? It will be equal to change in momentum divided by the change in time, like this. So we're just going to make our average force subject to the formula there. So from here, what else can we do? We can see that we're supposed to calculate the actual change in linear momentum, or rather in momentum, just in this case, of which we know to say change in momentum is equal to what? It is equal to final momentum, which is P final, minus initial momentum. This will be equal to what? It will be equal to mv final minus mv initial. And this is going to give me, if I factorize this and simplify it, I'm going to get m outside, then v final minus v initial there. So this is the formula that is going to give me my actual change in linear momentum. So this is going to be equal to what? We can plug in the values that we've been given. So we know to say mass is 0.250 kilograms. Then in the brackets, what do we have? We have final velocity, which is, in this case is negative 4.0, minus the initial velocity, which is 5.0, like this. This is in meters per second. I'll just put the meters per second outside there. Okay, so I'm going to remain with 0.25 kilograms. In the brackets, minus 4 minus 5, or negative 4.0 minus 5. This is going to give me minus 9.0 meters per second, like that. That means our actual change in linear momentum is equal to what? It is the product of 0.250 kilograms multiplied by negative 9.0 meters per second. So if I multiply these two guys, what am I actually going to get? I'm getting negative 2.25 kilograms per, or kg meter per second. So this is the actual change in linear momentum that is taking place under this scenario that we've been given here. So now that we've calculated the actual change in momentum, what are we going to do? We're going to get this value and plug it into the formula that we derived for force, and then find the average force. So we said average force is equal to change in linear momentum divided by the change in time. This will be equal to what? The change in linear momentum is 2.25 kilograms meter per second divided by the change in time. So this is the time that the ball and the wall were in contact with each other. Do not say that that time is 0.0150 seconds, like this. Okay, so negative 2.25 kg meter per second divided by 0.0150 seconds. This is going to give us an average force which is equal to negative 150 newtons. This is a force, and we know to say the SI unit for force is newtons, but I should take note to say we found negative here as the direction of the force. So what does this negative here imply? It means the direction of this force was opposite to the initial positive direction of the ball. So which means it was in the positive direction, the same as the second velocity that we had. So the average force was 150 newtons, but directed in the opposite direction from the wall. So therefore, we are finding the answer as 150 newtons, or rather negative 150 newtons as the average force that is acting on the ball in this case. Okay, so let's look at question B. Question B is saying the force is assumed to vary with time as shown in the figure. Find the maximum force that acted on the ball. The force is assumed to vary with time as shown in the figure. Find the maximum force that acted on the ball. So this is the figure that they are talking about. And if we look at this figure, it is a force time graph. It is a force time graph. So we can see there's time here, which is an interval. Then there is the maximum force here, which is at the peak here, just at the top there. There's a force, of which that is the maximum force that we're supposed to calculate in this case. So what else are we supposed to know before we perform any calculation in this case? So we have to know that the area that is under a force time graph actually gives us the momentum, the change in momentum in this case. So the first time graph, the area that is under the first time graph actually represents the change in momentum. And if we remember very well, we've already calculated the change in momentum in A. So that is making our question much easier. And if we use the formula for calculating the area that is under a triangle. You know, today this is a triangle. It has height, of which in this case, the height will be equal to the force. Then it has the base here, of which the base here is representing time. And we have the area that is under this triangle, of which this area that is under this triangle is actually giving us the impulse, or the change in momentum. So that is creating, or that is making our question even easier, because we know to say the formula for calculating the area under a triangle is half multiplied by the breadth multiplied by the h. So where are we getting these b's and the h? So note breadth is the time that is here. The h is the maximum force that we are looking for. And this formula, remember, it is equal to what? It is equal to the area under the triangle. And we say the area that is under the triangle is equal to what? It is equal to impulse, or rather it is equal to change in momentum. And we've already calculated momentum in question A, or in part A. So which means we're going to plug in that value there, plug in the time that we have. The half here is a constant, and we are looking for h, and h is the one that is going to give us the maximum force F in or on part B. So let's get into it as quickly as possible. Yeah, so this is question B. Let me start it on a fresh page. So part B, we'll say the area that is under a triangle, of which in this case it is change in momentum or impulse, will be equal to what? It will be equal to half multiplied by B multiplied by H, like that, of which the H is what is giving us the maximum force in this case. Okay, so we have the breadth as the time. So we found the change in momentum in part A, And we said what was the change in momentum. Let's just go back on top and check what we found. Where is it? Where is it? Where is it? Okay, we found it. The change in momentum as 2.25. So negative there is there to represent the direction, but I'll get the general change in momentum, which is a 2.25. So I'll say 2.25 is equal to 1 over 2 multiplied by the breadth, of which the breadth is the time that has been given under the graph. So this is 0.150 seconds multiplied by F max, which is the maximum force in this case. Okay, so from here, what are we going to do? We're going to make F max the subject of the formula. We're going to make our F max the subject of the formula. And by so doing, we're going to divide both sides by what? By half multiplied by 0.150. Even this side divided by half multiplied by 0.150. So this part cancels out. And what am I remaining with? I'm remaining with F max, which is the maximum force here, being equal to 2.25 divided by half multiplied by 0.150, like this. Okay, and if I plug these guys into my calculator, I'm getting F max being equal to 2.25 Newton per second or kg meter per second over 0.075 seconds, like this. Okay, so this is kg meter per second, like that. And if I divide these two guys, I'm getting a maximum force which is equal to 30 newtons. So that means my F max is equal to what? It is equal to 30 newtons. Okay, so that is the end of question 1. I've calculated both part A and part B. And the next one is question 2. So let's quickly look at the next question.